Hello everyone, welcome to Equal To, and this is the 12th episode of our number systems playlist. If you haven't watched the previous 11 videos yet, please go and watch that before watching this one. Now, in the previous video, we've solved all the questions from exercise 1.3, right? Now, we are moving to section 1.4, which is actually involving rational and irrational numbers and the operations in rational and irrational numbers. So instead of telling rational and irrational numbers separately, you can combinedly tell them as real numbers, right? So in this part of the chapter, we are going to look at operations with real numbers. Okay, now first we are going to look at example number 11, and in this video I think we are going to look at a couple of examples. So we'll just start, right? So example number 11, let me just read the question first. So we are supposed to check whether the given numbers are irrational or not. Okay, now we have also been provided with values of root 5, root 2 and the value of pi. So we have been provided these three values and we are supposed to find if the given numbers are irrational or not. Okay, now we know that root 5, root 2 and pi are in fact irrational. Okay, so let us start with the first subdivision here, which is 7 root 5, right? Okay, so 7 root 5 and the value of root 5 that we have been already provided here in the question itself. Okay, so the value of root 5 is 2.236. so that is the value of root 5. Okay, and we know that it is irrational and it is a non-terminating and non-repeating number. Okay, so it doesn't terminate and also not repeat itself, so it keeps on going. So these are the first 3 decimal points of root 5. This is not the end of it, it keeps on going. These are the first 3 decimal points. Okay, so we know for sure root 5 is a irrational number. So when we multiply that with 7, what would happen? Obviously we cannot do multiplication for the digits that keeps on going. Let me just do it for the 3 digits that we have here. Okay, so 7 times 5 is 35, 7 times 6 is 42, right? So 2, we have a remainder 5, 7 times 3 is 21, 21 plus 4 is 25 and we have remainder 2, 7 times 2 is 14, 14 plus 2 is 16, that gives you a remainder 1, 7 and we have a dot here. Okay, let that be there. 7 times 2 is 14 and 14 plus 1 gives you 15. Okay, so the value of 7 root 5 is equal to 15.652 and it keeps on going. Okay, so you cannot actually find the entire thing, it keeps on going, you will never be able to find the entire value. Okay, so the value of 7 root 5 is 15.652 dot 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 and so on, so many digits. Okay, now what you can tell is that this is not terminating and also it is not repeating. So obviously 7 root 5 is also irrational. Okay, 7 root 5 is also irrational in nature. Now we move to the next subdivision here, which is root 2 plus 21. Okay, root 2 plus 21 and we have been given the value of root 2 here, which is 1.4142 and so on. Obviously we know for sure that root 2 is irrational in nature because it is not terminating and non-repeating. Okay, now if we add this to 21, what would it be? It would simply be 22.4142 dot 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 and so on. So this is the value of root 2 plus 21 and obviously you can tell that root 2 plus 21 is also irrational because it is non-terminating and non-repeating. So this is also irrational, right? Now we'll move to the next subdivision, which is 7 divided by root 5. Okay, now 7 divided by root 5, we don't want to do it straight away. We'll do a simple transformation that would help you to find the value easily. Okay, so what we are going to do is that we are going to multiply this number with root 5 above and below. Now we know this we can do because root 5 divided by root 5 is 1, and 7 by root 5 into 1, 7 by root 5 times 1 is also 7 by root 5, right? So this doesn't violate any rules of mathematics, so you can do this. Now 7 into root 5 would be your numerator and root 5 into root 5 would be your denominator, right? Root 5 into root 5 is actually 5. So you will get 7 root 5 divided by 5. Okay, so this is the value. Now you can use the value of root 5 that has been given in the question. You can use this value and evaluate this. Because root 5 is irrational, it would be really difficult for you to divide 7 by that number, right? So we have converted it into a multiplication form. So 7 into root 5 divided by 5. But we have already found the value of 7 into root 5 in the first number. The first number that we found is actually 7 into root 5, right? So let us just use that here. Okay, so that is 15.652 divided by 5, right? Let us just use that value here to find this. So this should be 3.13 and so on, right? So approximately it is 3.13 and the number keeps on going. It is not terminating and non-repeating. So this as well is irrational in nature. This is also irrational, right? This is also irrational. Now let us come to the last one, the last number here, which is pi minus 2. The value of pi that has been given is 3.1415 and you are going to subtract the value of 2 from it, right? So 3.1415 minus 2, right? The value would be 1.1415 and it keeps on going, right? So this also keeps on going, and that would mean pi minus 2 is also irrational because it is non-terminating and non-repeating. Okay, so you have found values of 4 numbers: 7 root 5, root 2 plus 21, 7 divided by root 5 and pi minus 2, and all these 4 things are resulting at irrational numbers. Okay, so this is example number 5. Now at the end of this section we will be coming up with 3 properties, so wait for that. Now before that we will move to the next example. So here is the next example, which is add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So we have been given 2 numbers and we are supposed to add them. Okay, so let me just write these 2 numbers first. 2 root 2 plus 5 root 3. This is one number and you are supposed to add this with root 2 minus 3 root 3. Okay, now let us first group the similar terms here. Okay, now root 2 and root 2, those are similar terms, right? Root 2 and root 2 are similar terms, and 5 root 3 and 3 root 3 are similar terms. So you are going to group them together. So 2 root 2 plus root 2, this is one group, and the second thing is 5 root 3 minus 3 root 3, this is the second group. So we have sorted this, we have separated this into similar groups. Okay, we have segregated them. Now what you are going to do is that you are going to add this. Okay, 2 root 2 plus root 2 is 3 root 2, right? It's quite obvious, 2 root 2 plus root 2 is 3 root 2. And the second term, 5 root 3 minus 3 root 3, and that is 2 root 3, right? So 2 root 2 plus 5 root 3 and root 2 minus 3 root 3 is our question, and we have just rearranged the terms and have performed our arithmetic operation, and that gives you the answer 3 root 2 plus 2 root 3, and that is the answer to, and the value to the question, right? Okay, I hope you got this. This is not complicated. You have just rearranged the terms and performed an arithmetic operation. Okay, now we are moving to the next example, which is to multiply two numbers that have been given. Okay, the first number is 6 root 5 and the second number is 2 root 5. Now we are going to multiply these two numbers. Okay, so 6 root 5 times 2 root 5. Okay, now you can just write it as 6 into root 5 into 2 into root 5, right? I can obviously separate it like this and write. Now again I am just going to do a simple grouping and those sort of multiplication, right? Let me just draw it here. Okay, so 6 into 2 into root 5 into root 5. So we have just rearranged the terms that are present in this question. Now 6 times 2 is 12 and root 5 times root 5 is 5, right? So 12 into 5 and that gives you 60. So the answer to this question is actually 60. Okay, I hope you understood this. This is quite easy. We have just rearranged the terms and performed multiplication. Now moving on to the next question, you are supposed to divide two numbers. Okay, so the numbers are 8 root 15 and 2 root 3. Okay, now what I am going to do is that I am going to split this root 15 and express it in terms of root 3. Okay, now if we do that, we will be able to cancel these things out. Cancel the root 3 from the denominator with the root 3 from the numerator. So what do I exactly mean by that? Observe it carefully. So it is 8 times root 5 into root 3 divided by 2 root 3. Now do you get what I am trying to tell? Now root 15 has been separated and written as root 5 into root 3. Okay, so root 15 is equal to root 5 into root 3. So we have separated it and written it in that form. Now since we have root 3 in denominator and numerator, you can cancel it out. So what we are doing is we are essentially dividing the numerator and denominator by root 3. So that we have done. Now what we are left with is 8 times root 5 divided by 2. Now this 2 you can divide 8 by that and that would give you 4 root 5, right? And 4 root 5 is the answer to this question. Okay, now I hope you have understood this. This is very simple. We have been given two numbers, 8 root 15 and 2 root 3. Now we have expressed root 15 in terms of root 5 into root 3, and since we have expressed it like that and we have a root 3 in the denominator, we are able to cancel those out and we are left with 8 times root 5 divided by 2, and that value is 4 root 5, and that is the value of this entire question. Okay, so those are the questions that we have seen here. So we have seen the first question where we have found these numbers to be irrational in nature, and we have also performed addition, multiplication and division on irrational numbers. So now we are going to come up with inferences that we have observed so far. Okay, so the inferences are: the sum or difference of a rational number and an irrational number is irrational. So what they have said is that this is the first question, right? We have seen sum sum of 21 is a rational number and root 2 is an irrational number. So sum of irrational number and a rational number, that is irrational in nature. Now here 2 is rational and 5 is irrational, and subtraction of that gives you irrational. Okay, so sum or difference of rational numbers and irrational numbers gives you irrational numbers. So this is what we saw from example 1, or rather the first example that we saw in this video. I am not exactly sure what example number it is. Okay, so that is what we have seen. Now the second observation is that product or quotient of a non-zero rational number with an irrational number is irrational. So this also we have seen in example 1. So what we have seen is that product of a rational number with an irrational number gives you an irrational number. Okay, so 7 is rational here, root 5 is irrational here, and the product of those gives you irrational. And also 7 is rational here, root 5 is irrational here, so their quotient, by quotient they mean is division. So 7 divided by root 5 is also irrational. So this is the second observation that we have made. Okay, so this is also irrational, and this also is from example 2 as well. Okay, now the third observation is, if we subtract, multiply or divide two irrational numbers, then the result might be rational or irrational. So this is what you have to keep in mind. It can be rational or irrational. So in this example, we have been given two irrational numbers, 8 root 15 and 2 root 3. So these two are irrational numbers, but their division is also irrational here. Okay, but in the previous case we have two irrational numbers, 6 root 5 and 2 root 5, and their product gives you a rational number, 60, right? So by this they are telling that it can either be rational or be irrational. So we have found that these can be rational or irrational in case of multiplication, division of two irrational numbers. Okay, now also if we subtract two irrational numbers, it can also lead to a rational number. How is that? Let us take root 2 minus root 2, right? Root 2 minus root 2, that gives you 0. So that is a rational number. So subtraction can also do that. So these are the inferences that we get from the examples that we have seen. Sum and difference of rational numbers and an irrational number is irrational. Product or quotient, quotient meaning division. Let me just cut this and write division. That is just a fancy way of saying it, so don't worry about it. Of a non-zero rational number with an irrational number is irrational. If we add, subtract, multiply or divide two irrational numbers, we may end up with rational or irrational number. So how addition happens? Addition of two irrational numbers might lead to a rational number. How is that? Let us just take 2 plus root 3. This is one irrational number, and another irrational number could be 2 minus root 3. Now these two are irrational numbers, right? Now if we add these two, the answer would be 4, right? Because this root 3 and this root 3, they get cancelled, they get subtracted, right? So the answer is 4. So in addition also you might get a rational number. Addition of two irrational numbers might also lead to a rational numbers. Okay, so that is all for this video. I hope you understand all the things that we have discussed in this video. Thank you so much for watching this one. See you in the next video. Bye for now.